Question number 1, they gave us a linear equation, but they never told us the y-intercept. But what they did say is if we increase b by 4 units, mainly what we're doing is we're just adding 4 to the outside of a function. And if you know your function shifts, you will know that adding a 4 to the outside moves the function up. In this case, it would be up 4 spaces. Now, on the flip side, if you want, you can use your calculator to help us work through this one. I'm going to graph the function negative 2x plus, and I'm going to make up a value for b. Let's keep it easy for the first one. I'm going to make it 0. Then what I'll do is I'll graph another function and add 4 to 0. Well, if I add 4 to 0, I'm just getting 4. So my y-intercept instead of 0 is now 4. And you can see that this also shifted up the function 4 spaces. With question number 2, you should have created 2 linear equations for Rowan and for Jonah. And looking at both of them, you can see that I've highlighted the y-intercept in blue. And no, I don't mean y-intercept, silly me. I meant I highlighted the slope. The y-intercept is a 50 and the 10. So I highlighted the slope, and you can see clearly that 15 is much larger than 5, so Jonah's graph has a steeper slope. If you are not sure, let's graph them. And it's a little difficult to see right now after we graph them because the window isn't large enough, so we can change around the window. Another thing that I want to point out is even though I use W, my calculator only understands X. So what I could do here is I can change, because I know my Rowan equation has a y-intercept at 50. Let me just go a little bit higher, and you can clearly see that the purple line, the Jonah line, is definitely steeper than Rowan's. In question 3, I color-coded. So I highlighted everything that related to adult tickets in yellow and student tickets in blue. So the only 2 answer choices that would really make sense here regarding making sure that the 3 and the A are grouped together and the 150 and the S are grouped together would be answer choices 3 and 4, because those are the only ones that connect the 2 that I have highlighted. However, when we're dealing with the total amount of money collected at the door, what we're doing is we're adding. A lot of people think total means equals. Total does not mean equals. Total means you're adding. If you think you go to a restaurant, you want the total of the bill, you're adding up all the numbers. And you will eventually get a value as the sum of everything, but in order to total them, you're adding. Heading over to question number 4, the first thing that I recognized is that there were pieces of this that were factored nicely, and that's what I have highlighted here. So what I did was I took my factor and I set it equal to 0 to find the root. So I recognized that this x plus 2 gave me a root at negative 2, and this x minus 2 gave me a root at 2. Unfortunately, I don't have a root at 2, so therefore I got rid of answer choices 2 and 4. Moving on to narrow it down from 1 and 3, I factored what was remaining, and I factored this. You could have used the box method. I didn't need to do that, but instead I was able to find that negative 1 times 4 is negative 4, and they added to 3, and then found the roots there and saw that the root of negative 2, the first one, the root of 1, and the root of negative 4 all existed on here. Therefore, 1 was my correct answer. Now, those of you that didn't follow that, the easy way to kind of either go through this or to either check your work also is to just, you got it, graph it. Now, whenever you're in doubt if you should include a multiplication symbol when 2 sets of parentheses are touching or any point in time, you can always put a multiplication dot, which I did. If you hit enter, you will again see that the roots match up with the roots that are on the actual paper. And obviously, if you graph 2, 3, and 4, you will find that the roots are not the same. If you're not sure how to find the roots, you can always go into menu, analyze the graph. Another word for root is a 0, and you would have to calculate all 3 of them separately. Question 5 is very similar to question number 3. Here I color-coded, and I showed that the chewing gum was highlighted in yellow, and anything related to the bottles of juice I highlighted in blue. So notice how in the problem, only 3 and 4 have those connected. The last piece I have highlighted in green, it says Julia has $22 to spend. That means she has $22, but she can't spend any more than that. So therefore, I wrote out less than $22, but it could also equal. That's why we picked number 4. If you're ever not sure which is the less than symbol, make 2 L's with your hands, and whichever one actually does the correct L, that's the less than symbol. If you look at number 6, you will see that we're graphing 2 inequalities. The great news is they're both graphed, or they're both written in slope-intercept form. So all we have to do is look at the symbols. Both of them are equal, so both of the lines are solid, as with all of the answer choices. So that's not what we're testing, or this question's testing. It's testing to see, can you shade above or below? Do you know the difference? A less than symbol means shade below. A greater than symbol means shade above. So if you look at answer choice 3, the only one that makes sense is answer choice 3 because the shading is correct. Now, of course, there's a much easier way to either do this question or check yourself, and that's by graphing them. And remember, when you graph, you always want to change it to relation mode and just type in the 2 inequalities using control equal sign to access those inequality symbols. Here's my first inequality. And there is my second inequality, and you can see, yes, we were correct when we picked answer choice 3. With question number 7, you can see that the way that they wrote out 9.05 million is the same in every single answer choice. So that is not the problem, or not really what we're being tested on here. What they want you to do is understand that when the population is growing at a rate of 3.1%, we're really comparing this to 100%. So this is a growth of 103.1%. Okay, so if you look at the answer choices, we are going to eliminate 1 and 4 because both of those show subtracting. That is actually showing a decrease in the population, which is not good. We want to see an increase in the population. So now we've narrowed it down to 2 and 3. The only difference is one of them is 31% and the other one is 3.1%. Answer choice 2, the decimal was not moved over enough spaces. As you can see, if we write out 3.1%, and percent means per 100, so we're moving the decimal place not 1 but 2 spaces to indicate or represent that 100, we can see that answer choice 3 is correct. Number 7 is, there's not really a good way to use your calculator for this one. There are strategies, but we just need to look at the structure of whatever they have given us in the function. Now with question number 8, there was a lot of information that they gave you. They told you that there was a base fee of $62. Because there was a base fee of $62, I can immediately eliminate answer choices 1 and 2 because a base fee would look like a constant in a function. So I'm looking at a constant of 62 in answer choices 3 and 4. And then I noticed that the overage charge of 30 per gigabyte. So many of you might think, well, that would be 30G. But if you look at your 2 answer choices, that's not an option. So why is it not an option? Well, what I have bubbled in red indicates that it will exceed 2 gigabytes. For me, that means that it's going to go over 2 gigabytes. So what we'll have to do is subtract away the 2 gigabytes that we are getting that's included in the package. That's why we're going to look at the G minus the 2. If it helps you, you could create a table of values for this function, which you can see here. So 2 gigabytes would be $62, but anything over that, so like for every gigabyte over that, you would have to add 30. So graphing choice 4, we would be able to see the same table. All right, so here it is graphed. Notice how I don't care about the 0 and the 1. Right now my starting value is really when 2 gigabytes or in this case more are used. I don't care about the graph. I just care about the table to match the function, and it does. Yay.